Two wires are tied to the 300-gram sphere shown in figure P8.46. The sphere revolves in a horizontal circle at a constant speed of 7.5 meters per second. They want to know what is the tension in each of those wires connected to that sphere. So, gone ahead and redrawn our figure here. We have each wire at 1.0 meters. They've given us the height in between those wires, and they've given us the velocity of 7.5 meters per second. We know the mass of our sphere is 300 grams, which I've converted to 0.3 milligrams. And first thing I went ahead and did is calculated the theta here. So we can use that for our equations, and did that by using the sine of theta, because opposite over hypotenuse. And then take the inverse, and we get 30 degrees for theta. And then we can calculate r by taking, using the same trigonometry, take the 1.0 meters times cosine of our 30 degrees, and we get 0.866. I also drew another figure here just to kind of lay it out on a coordinate system, get a better idea of what forces are acting. We have our tension 1 for our first wire, and a tension 2 is our second wire, and then force of gravity, of course, acting on that sphere. And since we're working in uniform circular motion, since the sphere is turning around at constant speed, we're going to use z and r coordinates. So first, to calculate that z coordinate, we want to take our tension 1, and we want to times it by sine of theta to find that tension in that horizontal direction. So we take sine of tension 1 times the sine of 30, and that's going to equal that tension 2 times the sine of 30 plus the force of gravity pulling down on that tension 1 wire. So just did some math here, and we end up with tension 1 equals tension 2 plus 5.88. So we're going to save that to calculate later. So next we can calculate the forces on our r coordinate, and the sum of our forces this time is going to be equal to T1 times the cosine of 30 plus T2 times cosine of 30, and that's going to equal mass times velocity squared over that radius, because that is our equation for the uniform circular motion. And again, I've plugged everything in, ended up with T1 plus T2 is equal to 22.9. So now we can simply plug in that what we got for T1. We know T1 is equal to T2 plus 5.88. We can plug that in right here, end up with 22.9. More math, and we get our tension 2 at 8.51 newtons. And T1, just go ahead and subtract that 8.51 newtons. And we end up with 14.4 newtons for tension 1. So yeah, this problem helps us to understand the dynamics of uniform circular motion from what we're learning in class this week, and helps us practice with tension and forces.